Hi dear, today we'll see activity 1.8 and 1.9. Okay, so your activity 1.8 is take about 2 gram of silver chloride in a china dish. Place this china dish in a sunlight for some time. So okay, so we are going to take a silver chloride in a china dish. China dish is nothing but a small plate like structure, porcelain dish. So you have to keep 2 grams of sodium chloride in that you are under the sunlight, and you have to observe that reaction. Okay, so what is the observation? So you know that the silver chloride, color of this silver chloride is white. This is white in color. When kept in sunlight for some time, this white color silver chloride turns gray. Okay, gray in sunlight to form silver metal and chlorine gas. Okay, the gray color substance formed is the silver metal, and this chlorine will be evolved as a gas. Okay, so what is your conclusion? When silver chloride in the presence of sunlight, okay, light energy, here it absorbs the light energy, it helps in the breakdown of silver and chloride, okay, chlorine to form silver plus chlorine gas. Okay, so this is one single compound breaks down into two different products. Okay, so that means what? That is decomposition taking place. What type of decomposition? It is a photolytic decomposition, because light energy is used in this reaction. Okay, so the sunlight light energy from the sun is used in this reaction to break down this AgCl into Ag and Cl. Clear on this? So this reaction is a photolytic decomposition reaction. Since the sunlight is absorbed, it is used for this purpose. It is an example of endothermic reaction. Clear on this? So this you know that this concept, this is a basic concept used in this black and white photography. Already we learned that, right? The same way the silver bromide also behaves. Okay, so what is that? Silver bromide is AgBr. This is your solid in the presence of sunlight. Okay, it gives Ag solid plus bromine gas. Okay, so what is this? Color of this silver bromide is pale yellow, which is pale yellow in color, which turns into gray, metallic gray color in the presence of sunlight. Okay, so this is also used in the photography. Okay, when silver bromine in the presence of sunlight, it decomposes into silver plus bromine gas. Okay, so here the light energy is used, so it is a photolytic decomposition, and also an example of endothermic reaction. Okay, next we move to the activity 1.9. Activity 1.9. Okay, here take 3 iron nails and clean them by rubbing with sandpaper. Okay, so always metals, when exposed to air, it forms oxides on the top, on the surface of the metal, right? So it has to be always rubbed out to react with the metal directly. Okay, take 2 test tube marked as A and B. In each test tube, take 10 ml copper sulfate. CuSO4 means what? Copper sulfate solution. Okay, tie 2 nails with a thread and immerse them carefully in the copper sulfate solution in the test tube B. Okay, we are going to take copper sulfate in 2 test tubes A and B, and we are going to immerse the nails only in the test tube B for 20 minutes and keep one nail aside for comparison. Okay, so we have to check what is the color of the nail before reaction and after reaction when kept in the copper sulfate solution. After 20 minutes, take out the nail from the copper sulfate solution. What are your observation? Okay, so we are going to take 3 nails, and we are going to rub that nail with the sandpaper to remove the oxides, iron oxides formed over the nail, and for for the reaction with the iron directly, okay, because iron oxide will be formed on the metals, right, iron nails, so it has to be removed. That's why we are rubbing with the sandpaper, okay. Then you have to take the copper sulfate solution in two test tube, A and B. You know that the what is the color of the copper sulfate solution? This is blue in color, okay, blue in color, okay. So you are going to keep the nails in the copper sulfate solution only in the test tube B, and we are going, you are not going to touch the test tube A, okay. We are going to keep the copper sulfate solution as it is, okay. After 20 minutes, what is your observation means? A brown color substance deposit on the iron nail, okay, brown color substance deposit on the iron nail, and the color of the copper sulfate solution becomes faint, okay. So what are your observation means? So this is your setup. Here this is a copper sulfate solution, test tube A. We are not going to keep the nails here. We are going to keep the nails only in this test tube B, right? So what your observation will be, this iron nail, this is the comparison iron nail. This is before dipping into the copper sulfate solution. After 20 minutes, a brown deposit substance will be deposited over the nail, okay, and the color of the solution, this is B test tube where we kept the nail, it becomes faint. You can check with the original color of the copper sulfate. This is the original color of the copper sulfate solution. After 20 minutes it becomes faded, slightly faint, okay. Why means, when this iron solid iron reacts with copper sulfate solution, this iron will replaces this copper from the copper sulfate, okay. This is more reactive, this iron is more reactive, so what it will do, it will remove this copper sulfate copper from the copper sulfate solution, okay. So it forms iron sulfate plus copper. This copper is deposited over, the solid copper is deposited over the nail. That's why the nail color become that is the brown color deposit. Brown color substance deposits, no, this is nothing but your copper deposited over the iron nail, okay. Why the color of the copper sulfate becomes faint means, some of the copper is replaced by the iron, so it is become slightly greenish in color. If you leave it for a long period, it fully faded, okay. So this is an example of displacement reaction. This iron displaces the copper from copper sulfate solution, okay. Clear on this? Next, what will happen if you dip the copper in the iron sulfate solution? Do you think any product will be formed? Do you remember the displacement reaction previously we learned? Remember that this copper is less reactive than iron. That means the reactivity they are telling about their strength, okay. This is very strong, it is strongly placed. This copper will not be able to replace this iron from the iron sulfate solution, so there is no reaction, okay. If you dip a copper plate, this is copper plate, this is a copper plate in a iron sulfate solution, no changes, no reaction will take place. Even after 1 hour, if you take the copper plate will be in that brown color only. You know the color of the copper, light brown in color, right? Cu plus FeSO4 gives no reaction. No reaction will take place, okay. Likewise, zinc when dipped in copper sulfate solution, the zinc will replaces the copper because zinc is more reactive than copper, okay. So it forms zinc sulfate plus copper. Likewise, lead plus copper chloride give lead chloride plus copper solid. Why? How copper. So how do you know that which one is more reactive and which one is less reactive? Already I told you, this reactivity series based on the reaction. They have formed some reactivity series in the chemistry. Okay, this is actually relative reactivity series. Relative reactivity series. We are comparing. When compare with the something in two things, which one is more reactive? Based on that only this reactivity series has been framed. Okay, this is more reactive. This is more reactive, and when coming down it is less reactive. Less reactive. You know that gold will not react. We are using it daily, right? It is less reactive. Okay. So some of the things metals will differ here in between this, because we have prepared this chart based on the relative reactivity series, comparison between the two things only. Based on that only we have created this. Okay, few reactivity series contain few metals, some may not have. In our book, in NCERT book, they are given this reactivity series, so we can take this one. Okay, so which is more reactive? Potassium. Next, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen. This is a non-metal, you know, since it is electropositive in nature, it is kept here. Copper, mercury, silver, gold. Okay, copper, mercury, silver, gold. Okay, so if you see this, see copper first, iron and copper. So iron is more reactive than copper. That's why the iron replaces the copper here. But when you keep the copper in the copper sulfate solution, this copper will not be able to replace the iron, because this iron is more strong. It is not able to replace the iron. So there is no reaction taking place. When we dip the zinc in copper sulfate solution, zinc is more reactive. So it replaces this copper, and it forms a zinc sulfate solution in this reaction, right? Likewise, lead is more reactive when compared to copper. Lead is more reactive when compared to copper. So it replaces the copper from copper chloride and form lead chloride. Clear? So I have given you mnemonics to remember this reactivity series. Okay, so the name potassium, sodium, calcium, you can remember this by mnemonic, one of the mnemonic. You can use your own mnemonics also. Okay, I tried this one. Please stop calling me a zebra. I like her calling mighty smart guy. Okay, mighty smart guy. Please, potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. Okay, you can remember this by, if you want, you can during the exams you can write, please stop calling me a zebra, I like her calling mighty smart guy, and then you can find which one is more reactive and which one is less reactive. Clear on this? So you know that in the displacement reaction, more reactive metal will replaces a less reactive metal from their compound. Okay. So you hope you understand this. This is the observation. What is the observation in activity 9.1? Brown colored substance deposits on the iron nail. That is nothing but where copper deposits on the iron nail, and the color of the copper sulfate solution becomes faint. This is the observation, and this is an example for the displacement reaction. Okay, this is an example for the displacement reaction. This Fe is more strong, so it replaces the less reactive copper, and it forms iron sulfate and a copper. Clear on this? Next we have one small activity given in the book. It's not an activity, just going to observe this reaction. What is the reaction? Take 2 gram of barium hydroxide in a test tube. Barium hydroxide. Barium hydroxide means what? BaOH twice plus ammonium chloride. Ammonium means what? NH4Cl. NH4Cl. NH4Cl, ammonium chloride, and mix with the help of the glass rod. Mix with the help of the glass rod. The question is, what if we touch this? It is here. Touch the bottom of the test tube with your palm. What do you feel? Is this an exothermic or endothermic reaction? Okay. In this reaction, this barium hydroxide and ammonium chloride will react to form barium chloride plus ammonia plus water. Okay. So in this reaction, it is an endothermic reaction. No, what is this? It is an endothermic reaction because it absorbs heat from the environment. It absorbs heat from the environment, okay, and use it for the reaction. Okay, it absorbs heat from the environment, so it is an endothermic process. It is an endothermic process because it absorbs heat from the environment. So it absorbs all the heat, means the environment becomes very cold. Okay, so if you touch the bottom of the test tube, the test tube becomes very cold due to the absorption of heat from the atmosphere. It absorbs all the heat from the surrounding environment, so it becomes very cold there. Okay, so this is your observation. It is an example of endothermic reaction. Okay, thank you.